Hello, my dear students. Once again, welcome to Chemistry Bridge course. So today we're gonna continue from where we have stopped. So in the last class, what we have discussed is we have started with the atomic structure only. There we have discussed about very few basic that how the atomic theory has been started, how different ideology has been changed slowly. So all those things were the basic, and it was just the beginning. It was just the beginning of new era. So later, they have slowly started experimenting the things. They are just not concluded. They are just not told the things based on their experience. They have done something, and they have experimentally proved many things. So let us let us try to learn today how the atomic structure has been slowly developed, and what are the new types of experiment they have conducted, and by that what they have concluded. So let us learn about that. Okay, so here in the this is the second part now, so therefore it is given as a part 2. Again, it's about the history and introduction about the atomic theories. So these are the common things that all these things will not be learned today. So we'll be mainly learning about the discovery of electron and discovery of the proton, how they have experimentally discovered this, and by discovery of this, what all the conclusion they have given. Let us learn about this, and based on the discoveries and based on whatever they have concluded, what type of a different atomic structure was given, that part we'll learn in the next part. So today we're going to learn mainly about the discovery of the electron. As we know that in the previous classes, that in the first era, okay, in the first time of the atomic, when they started thinking about the matter and what the matter is made up of, so they are just thought that there is something very small particle that is just reason for whatever we have around us now. So they thought that the small particles are the reason they are made up of, okay, and they were not knowing about anything about those small particles. So they started thinking about what might be it, and what that particle may be composed of, or what if we do some research on that one, if we do some, or if we supply some current or the magnetic field, all these things, what we're gonna observe, all this they think, they have thought about this. So because of their thinking only, we have now that what atom is may look like. It's not exactly still now known. Still we can have a little bit idea that what it might be having. So at the beginning, okay, at the beginning it is mentioned here that, so a British scientist called as William Crook, so what he has noted is when a voltage or very high voltage or high current is supplied, what he has saw is, so first of all we must know the one basic thing is that the gases are not good conductor. Okay, the gases around is not a good conductor. Luckily they are not good conductor, otherwise it would carry current, and it would, even if the gas in this area would give me the shock, but luckily they are not good conductor. But it is mentioned here that the gases at very low pressure, okay, the gases at very low pressure, they usually become little bit conductor. See, it's mentioned here when the William Crook noted that high voltage is applied to the tubes filled with the gases at very low pressure, the gases which are ordinary non-conducting become good conductors. So why they are becoming good conductors, or what is the reason behind their conductivity? So all these things were studied later, okay, not by the William Crook. He has just observed this phenomena, but he was not sure that why this type of observation he has observed. So he's not sure about that one. So slowly started thinking about what might be it, but the answer was not given by him. Okay, the William Crook didn't give any answer. He just conducted some experiment. He has been slowly observed that, he has just observed that the gases are becoming very good conductor. Why they are becoming good conductor, he was not having any idea. So let's try to learn about that now. So he but he has given one name for that. Okay, he has given one name. Why he has given name is the gas rays, okay, that conducting particle, whatever you observed, okay, it was because of the some rays. Okay, it was because of some rays. We'll learn about that now. Okay, it was because of some of the rays, and it was started, okay, it was started at the anode side, okay, anode side, uh, sorry, it was generated at the cathode side and it was traveling towards the anode. I'll tell you what is anode and what is cathode now, but before that you'll understand that it has generated from the cathode and it has traveled towards the anode. So therefore he called that one as a anode, sorry, cathode rays. Okay, cathode rays was given, the name given by him only because it had started, okay, it has started from the cathode. Okay, so let's learn now. Okay, let's learn about the next part now. So whatever he has conducted, the experiment, let me show you what he has conducted. See, so what he has conducted will come to know. Okay, so the J.J. Thomson conducted some experiment now on based on whatever he has observed. He just observed it, but he didn't conclude anything because he was not knowing anything, because at that time it was only believed that everything is made up of atoms, and atoms are something which is very small and we cannot divide it into any part, and there is nothing inside the atoms. Okay, atoms are the smallest thing. So they were not knowing anything about electrons or protons. Now we know that, but that time they were not knowing it. But it was proved by one of the greatest scientists, okay, but that is called as J.J. Thomson. So he has conducted a similar type of experiment. So you can say it's here. He has also done the experiment in which he used a tube known as a discharge tube. Okay, discharge tube. Discharge tube is something which is maintained usually at a low pressure where the gas will be filled, and it contains two electrodes. Electrodes means two metal plates, and here we'll be connecting battery, and we know battery has a positive and negative side, and that is what we call the name as a cathode and anode. Okay, the one side which is having a positive, the other side will be having a negative. Okay, so he has studied some characteristics of the constituent cathode rays. Okay, he has only again generated cathode rays, but he has studied clearly about what might be it and why it is, what is the property of that, all those things he has studied. So let us learn about that now. Okay, see here, what you see here, okay, that is what we call as a discharge tube. Okay, discharge tube, you can see it consists of a glass plate. Okay, it consists of a glass plate, and the reason for the using of the glass plate is so that he can observe. If something is made of glass, I can observe clearly what is going on, say, inside, right? Okay, and you can see two electrodes are there. Electrodes are some metals now. Okay, electrodes means some metals, and this was connected to the battery now. Okay, to the positive and negative terminal. To that part where the positive is connected is called as anode. Now it is very easy to understand, the one ion which move towards the anode should be opposite of this. Here it is, anode is positively charged, so anions will move towards this one which are negatively charged. Okay, anions or anything which carries negative charge will move towards the anode. Got it? Here it is cathode now, and from which side it will be generated, because it is having that negative charge, so negative charge will be generated from the cathode side. Okay, therefore it was named as a cathode rays. Okay, let's learn. Also, the discharge tube is a hard glass tube. As I mentioned, it was a hard glass tube. It is not like very light, because after decreasing pressure and all, it may break. Okay, it may break, and it is mentioned here that to the vacuum pump, right? Reason, to decrease the pressure. Okay, so here the metal plates are known as electrodes. That I also told you, these two are the metal plates. An electrode that is connected to the positive terminal of the battery is called as anode, means this one. Anions are negative, so that travel towards the anode, so it is positive. And the other electrode which is connected to the negative terminal is called as a cathode. Correct? This is cathode. Okay, let's understand what he has done. So here, what has done is he has side tube which the gas can be pumped off by using a vacuum pump. Means whatever the gas, usually it will be filled. Okay, whenever I take a glass now, there will be gas. Only thing, yes, he has decreased the pressure now by the using of vacuum pump. Okay, by the use of the vacuum pump, he has removed some gases here, so that the pressure over here will be low pressure is maintained. Okay, just at the beginning we have learned that at the low pressure usually gases become good conductor. Okay, but it should have something to carry the current now. So what is that thing which was carrying, that only he has studied now. Okay, so when the high voltage of around 10,000, very huge, right? In our home and all, whatever the voltage that we get is around 220 or 230 maybe, but here it is almost like how many times, right? Around 50 times more than that. So he has used the voltage of very high voltage of around 10,000 voltage, and he has passed the current at around very low pressure of 0.01 mm, right? It is very low. Now the pressure is around 760 mmHg, but this has used, he has used around 0.101 mmHg, and cathode rays are produced. Means at that pressure, the something, okay, the something which was not moving easily at high pressure started moving towards this side. Okay, understand, I'm mentioning something because at that moment they were also knowing what is that something is. Now we know that it is electron, because at that high voltage electrons will be kicked out from this. Okay, the cathode, from the cathode side electrons will be kicked out. You can see this electrons, got it? So at that moment they were not knowing what is that thing which is coming out. Okay, and it was coming out only at two conditions. One is by applying very high voltage and by maintaining very low pressure. So they have done both the things. When they applied very high voltage and very low pressure, that thing was coming out. I'm mentioning once again, that thing was nothing but the electron, and because of low pressure, now the gases are good conductors, so it was moving now. Okay, anyhow, it contains anode side which is positive, and we know now that electrons are negative. Definitely it will move towards negative, will move towards the opposite charge, means positive charge. So this is the thing, okay, that you observed. But let us learn now. Okay, what is done here is, what he has observed is the rays travels from the cathode. Okay, understand that rays is nothing but it was having the electrons. Okay, and it traveled from the cathode to the anode side, right? It has traveled to the cathode to the anode side now along a straight line. So it was moving in a straight line from the cathode to the anode, and these rays causes greenish yellow color. Okay, at usually low pressure, it produces color. Okay, because of transition. Now we know that electrons used to transit like this, but at that moment it was not done, and it was observed again only at the low pressure. So these rays causes the greenish yellow fluorescent in the soda glass tube, means the glass tube that you have used. Okay, so understand this way. So there was a glass tube, so they applied voltage. Slowly the electrons, means at that moment they were not knowing it was a electron, but they saw that something was moving towards anode. Okay, something was moving towards anode, means positive charge. Something was moving towards the positive charge, and it was moving in a straight line, and also it was producing the color. Okay, just now also we know there are so many the tube lights that we use produces some color, right? That also produces some color. It was all because of this only. So these rays are affected by the electric field. Now it is very easy to understand why they are affected by the electric field, because they were having charge. Because now we know that it is electron. Okay, but at that moment it was not known, but now we know that they will be affected by the electron. The reason is they are having charge. Which charge? Negative charge. So they are deflected from the negative field. See, negative charge will be definitely deflected by the negative field. It will get attracted towards the positive field. Okay, this show that they carry the negative charge. See, now we know, right? But at the moment they conclude that since they were moving away, if this was the negative charge you maintain, if the electrons were moving, it would move away like this. The reason, because the electrons were also having the negative charge. Okay, so by that he has concluded, okay, by these observations he has concluded that cathode rays consist of negatively charged particle, and they are called as electrons. Okay, so very simple, right? What he has done here is, he has taken a tube. Okay, he has taken a tube and he has charged. Okay, he has passed some current from this side. He has passed some current, and he observed that from one of the end, means from the negative side, some electrically charged particles were generated, and it was moving towards the anode. Now since it was moving towards anode and it was deflected by the negative field, he understood that rays which were traveling, it was carrying a negative charge. Okay, so he concluded that thing that was coming out was from the atoms itself. Okay, it means it will be there inside the atom. It was not known that where it was, but it was there in the atoms, and it was kicked out by the metal by applying high voltage, and by applying low pressure they were slowly started moving towards the anode. Clear? And he concluded that negatively charged particles are called as electrons. Got it? So J.J. Thomson is given this name, called as an electrons. Now also we use it, right? And we know the property, electrons are negatively charged. It will be there in the atom. how it will be there and all, we again will understand by the theories they have given. But one thing is sure now, that they travel towards the other side. Okay, now, so the properties of cathode, whatever that told now, that is there here. See, when a beam of cathode rays falls upon a hard metallic targets like tungsten, X-rays are produced. See, this is how the X-rays are now also it is produced. Okay, means you will be making a charged particle to fall on a tungsten, okay, or any metal, where electronic transition takes place. If the electronic transition is of low field or the low wavelength, then it will produce some color, it may produce some heating effect. If it is of very high frequency, it would produce X-ray. And they were penetrating to the matter. Now the electrons are very charged and very powerful. They can penetrate through some of the materials, and they can ionize the gas when they pass. That's the reason we are observing the color. Ionization means removal of the electrons, right? Removal, if this is an atom now, removal of electron is called as ionization, and that electron was kicking out some of the electrons in the atom, therefore it was producing ionization. And by some other experiment, they have calculated the E, means charge over that, and mass over that, and E by M ratio also. Okay, so see that I'll mention here. Properties of the electron, here it is mentioned, charge of the electron, it carries around minus 1.06 into 10 to minus 19 coulomb. Now you might wonder why it is minus, right? Charge couldn't be minus, right? But it is minus just because they are negatively charged. It is mentioned that they are minus, otherwise its charge is like 1.602 into 10 to minus 19 coulomb. Okay, that is the charge. Got it? And the mass, if you see, it is minus 31. Okay, it means around it will be like 0.000000, so many 30 zeros, then it will be 9108. Okay, it means its mass is very light. How much light it is? It is almost 1 by 1837 times of the mass of the hydrogen. If you consider a hydrogen, we know it is lightest element, and the electron which was there in the hydrogen was having only 1 by 1837 times of that mass of that hydrogen. So much light, right? If an atom is weighing around 1837 grams, okay, that much weight will not be there, but imagine it weighs that much, an electron would weigh only 1 gram. Got it? That much light. Got it? Okay, so by this they got that atoms are actually found to be electrically neutral, so there are must be positive charges in that. Now we know that atoms is made up of small particle. It was believed that it does not contain anything, but now only we just got to know that it consists of a negatively charged particle. In that case, every atom would have been negatively charged, but no, every atom is neutral. Why? Because it also carries the positive charge also. They thought in this way. Okay, it's very good thinking. They thought that okay, if atom is electrically neutral, and we got to know just now that atoms are made up of electrically negatively charged particle, in that case, if you want to make it as a neutral, there should be the positive charge also. Okay, so by that they again started discovering that. So it's mentioned, see, atoms are found to be electrically neutral, so there must be a positive charge that is equal to the charge of a negative charge. Means the charge should be equal, only thing is magnitude. The electrons will have a negative charge and this will have a positive. They realized that led to the discovery of the positively charged subatomic particle called as a protons. Okay, by this they have concluded that okay, there should be something positively charged, and they named it as a protons. So this is just a discovery. Now the same thing, same type of setup it is there, only thing is this different scientists have done that one. That is a Goldstein has discovered this one, and he used the same apparatus. I told you, know, it is same, but the cathode rays was positive to it was found towards the anode, so therefore the protons positively charged should find towards the cathode. Okay, and it was generated through the anode, therefore it is called as an anode rays. Okay, so again, see, the same setup, nothing changed, but only thing he has observed done here is he has made holes in this one. Okay, he has made holes in this one to observe anything which might be striking this side, and he got that. Okay, and we can understand that the cathodes are usually negatively charged, so something was going through this, or something was getting attracted towards this one, so therefore that thing which was attracted towards this one should be positively charged. Okay, so by that they conclude that yes, there is a positive charge also. So it is mentioned that only it was seen that the when cathode rays were produced and traveled through the gas in the discharge tube, while doing so they ionized the gas and they took the electrons from the gases, leaving behind the positively charged particle. It means, imagine there is an atom here. What is mentioned over here that I'll tell you. Imagine this is an atom now. The cathode rays, okay, the cathode rays means, see, imagine this is an atom now. The cathode rays that was coming used to kick out the electron from this one. So this red thing that is shaking now is only becoming a positively charged, and that will travel towards this one. Got it? It will travel towards this one with a straight line, the same as this. I hope you understood. So this is that atom. This electron would kick out the electron. Okay, this electron which is coming, that red rays will kick out the electron. So atom remains, that is a positively charged. Now immediately it travels towards this. So why it is positively charged? Because it was having a positive charge, just like electron. So after the removal of that electron, it becomes negative positive charge and it will travel towards the cathode. Therefore it is called as a cathode ray, and it is called as a protons. Got it? So here these rays are called as canal rays or anode rays, and they pass through the holes of the canals of the cathode and named it as a positive charge, called as a anode rays or proton. So observation again, it moves in a straight line. They also produces some color or fluorescence. Okay, they are made up of positively charged particle as that of a, and they are deflected by the electric field, but in a direction opposite to that of a cathode ray. Means if these are the direction of the electron and proton, they would move opposite direction. Okay, in the electric field, same electric field, they will move in a different direction. Conclusion is anode rays consist of a positively charged particle that are called as a protons. Okay, so again the properties of anode rays would be same. These rays consist of a minute particle, hence produces mechanical effect. Again, mechanical effect means that only rotating all those things. Again, when they found the mass to charge E to E by M ratio, so they got to know that the value would be little less because it is little high, mass will be higher. Okay, properties again, see, you can see the charge is same, but only thing is here positive. That was a negative, it's positive because they are positively charged. Okay, and mass is 1.6727 into 10 to minus 21 grams or minus 27 kg. Okay, that's the reason they were around 1837 times heavier than the electrons. Okay, so today what we have learned is about the discovery of electron, similarly about the protons and the cathode rays and the anode rays and their property. Got it? So we got to know now that every atom is not made up of only atoms. There is subatomic particle also, and that is electron and proton. Now you might ask that there is one more also, but I'll tell you why I'm not telling about that one now. Okay, now let us understand, okay, that how they will be placed, how they are taught, that how it might be arranged in an atom. All these things they started thinking, and they have given some conclusion about that one. That part we'll study in the next class. Okay, so yes, thank you.